Example 3. So example 3 again, we've got another equation we need to solve first, but we need to be very, very careful about this. So please do not divide both sides by cosine theta, because it is possible that cos theta could be equal to 0, and we're not allowed to divide by 0. So we need to be very careful about dividing by anything that could possibly be equal to 0. So what we're going to do instead is we're going to subtract cos theta from both sides. So we get 2 sine theta cos theta, subtract cos theta equals 0. And now what we can do is we can factorise a cosine theta. So we get cosine theta sine theta minus 1 equals 0. And then we have two possible equations here with either cosine theta equals 0 or sine theta equals a half. And we see now why we weren't allowed to divide by cosine theta, because we would have lost this solution. If we divided by that, we would have just got this, and we wanted both of them. So we do need to solve both of these, and by just thinking about our cosine graph and where cosine is equal to 0, we can see that that is going to be here and here. And if we're thinking about giving these solutions in radians, this is 2 pi, this is pi, so this is halfway here, this is pi over 2, and this is 1.5 pi, so 3 pi over 2. So our first solutions to theta are pi over 2 and 3 pi over 2. But we also now need to think about sine theta equals a half, and we are looking between 0 and 2 pi here. So we're going to draw sine from 0 to 2 pi, and we have sine theta equals a half. So we have two solutions here and here, and we know that this is pi and this is 2 pi. So if we do sine inverse of half, that should be one that you know is 30 degrees. You can do it on your calculator if you don't know that. 30 degrees in radians is pi over 6. And then finally, our final solution is this one here, where we can see that that final solution is pi subtract pi over 6, which is 5 pi over 6. So we have x equals 5 pi over 6 and theta equals 5 pi over 6 and pi over 6. So we have our four solutions to this equation. Right, let's get a little bit more complicated now. So before we look at example 4, I'm going to remind you of these two important identities, and you need to be out on the lookout to use these. So here we have, in example 4, we've got 9 cosine square theta plus 6 sine theta, subtract 10 equals 0. And notice that we're being a little bit tricky here, because now we want solutions between minus pi and pi. Okay, well, how are we going to handle this? Well, it is a little bit annoying because this has a cosine in it, but also has a sine. We want to try and end up with just cosines or just sines. Well, we know we can do that by using this identity here. And in particular, we know that cosine squared theta is identical to 1 minus sine squared theta. So substituting this into an equation, we will end up with 9, open brackets, 1 minus sine squared theta plus 6 logs of sine theta, subtract 10 equals 0. And expanding that out, we get 9 minus 9 sine squared theta plus 6 sine theta minus 10 equals 0. And actually that is, I'm going to add everything to the right hand side. So 0 equals 9 sine squared theta minus 6 sine theta. Add 10 subtract 9, so plus 1. And that is a quadratic in sine theta. And if it helps you, you can let y equals sine theta here and write this as 0 equals 9y squared minus 6y plus 1. Let's see if we can factorise that. We might not be able to, but there's a quadratic, so a sensible thing is to try and do factorise it. Well, we're going to need a 1 at the end of each of these. And actually, either they are both positive or they're both negative, but we need a minus 6y, so they are both negative. And if we have a 3y here, a 3y here, so actually what we have is 0 equals 3 minus 1 squared. So, moving up to the top here, we have 3y minus 1 equals 0, or equivalently, 3 sine theta minus 1 equals 0. Rearranging that for theta, we get for sine theta, we get sine theta to the third. And now let's think about our sine graph and where our solutions are going to be. Well, we only need to go between minus pi and pi, so we can see our two solutions to this equation are here and here. And sine inverse of a third is not one of those nice values that we should know. So on our calculator, making sure it's in radians mode, sine inverse of a third is approximately 0.3398 radians. So that is one of our values of theta, 0.3398. But the other value is going to be this one here. And we can see that this is going to be pi subtract 0.3398, which is approximately 2.8018 to 4 decimal places. So these are our two solutions to our equation. Okay, finally, example 5. So again, we've got quite a nasty looking equation with sine x subtract tan x equals 2 cos x tan x. So that's a bit horrible because we've got all of our trigonometric equations here. It's not really obvious what to do. But something you might want to try is we do know that tan x is identical to sine x over cos x. So we make this substitution for both of these tan x's and see what we get. Well, we get sine x subtract sine x over cos x equals 2 cos x times by sine x over cos x. So, well, that looks good because we can see that these two cosines cancel. So we have sine x subtract sine x over cos x equals 2 sine x. Well, what might be a nice thing to do now is to multiply both sides by cosine x. Well, if we multiply the right-hand side by cosine x, we get 2 sine x cosine x. And being careful here, we need to multiply both of these terms on the left-hand side by cosine x. So we get sine x cos x minus sine x. Okay, well, if we subtract sine x cos x from both sides, we get minus... Actually, let's subtract 2 sine x cos x from both sides. Well, what do we get? Here we'll get 1 sine x cos x, subtract 2 sine x cos x, which is minus sine x cos x minus sine x equals 0. And then taking a factor of perhaps negative sine x here, we get cos x plus 1. And be careful with this plus. It is a plus because we have minus sine x. Okay, well, we need two things that multiply to make 0. So either sine x equals 0 or cos x is equal to negative 1. And let's go back for what range of values were we asked for? We were asked for x being between 0 and 2 pi. So thinking about a sine graph, where is sine equal to 0? Well, it is equal to 0 when x is 0. It is equal to 0 when x is pi. And notice we weren't including 2 pi here. This was a strict inequality. So we are not going to include this point. So our first two values of x are 0 and pi. And then finally we need to deal with cosine x equals negative 1. Well, here is our cosine graph, and here is our negative 1. This is our line of symmetry through this part of through cosine. So we know that this line of symmetry in degrees, that's 180, but we know that is pi radians. So the only value here is pi. But notice that is one of our solutions already, so we don't need to write that down again. We've just got x equals 0 or pi. And there are only solutions when x is between 0 and 2 pi, not including 2 pi.